So I set myself a challenge this year, because I'm from the GRC side of the world, that come to a talk which potentially generally from the cloud and pen testing side of the team, I decided actually I'm going to try and change things up a bit. Try and put my footprint on this and actually have a chat about something that's really dear to my heart and something that has been a continual source of frustration for me for some years. So today I'm on a bit of a chat around supply chain security in the health sector, because what could possibly go wrong there, around software bills of materials and digitally enabled medical devices. And my intention is not to terrify anyone that next time they go to hospital all things on their wrist will kill you, but it does give you an idea of some of the stuff that's out there and that is not necessarily that well understood. So a little bit about me. I am the Deep South Yeti. My colleagues at ZX know me at that because I live in Dunedin. I have the rare privilege of going to work full-time remotely from home out in the Otago Harbour. Anyone from that part of the world will know it's a pretty sweet slice of heaven down there. So I daily annoy, harass, and generally make a nuisance of myself and my colleagues in Wellington, but I'm very lucky that they let me work there remotely. I'm a lead consultant, which basically means I make up a little bit of stuff that's slightly more than someone else to pretend like I know what I'm doing, which I don't. But I have been, prior to this, I was the the principal cybersecurity consultant at CCL, and then I was the chief cybersecurity advisor of the Ministry of Health, which my role was to lift the overall cybersecurity maturity of the health sector, both public and private, by influence and leadership. And I said, okay, I'll get that done by lunchtime, then I'll find something else to do. As you can see, it's a recurring issue that's still being worked on. And then, much like Ben earlier, I spent 10 years in the organisation that shall not be named. The last 4 or 5 years was at the working with organisations who are key economic generators and critical national infrastructure. So that was kind of interesting. Next slide, please. So what we're going to cover off today is what is a digitally enabled medical device, and as we'll talk about, there are some things that you won't necessarily think they are what they are. What are the threat and motivations for attackers in that regard? What are the cybersecurity challenges that we actually find in medical devices? What are the current threats and things we're seeing out there related to devices? Some recent compromises. A hacker conference isn't a hacker conference unless you've got some good war stories. What is the software bill of materials in this context, and how does that relate to a lifecycle-based approach in terms of managing medical devices? How do you implement and adopt? What might we do in this space? And next steps. Full disclosure, this is a slight rant. This is a really important topic for me, and I think it's really not that well understood. So I'm hoping we can build a little bit of awareness today. And also, because I'm an old man, I might refer to some notes as well, so please bear with me. Next slide, thanks. So, what is a medical device? It is actually something that a lot of people may not necessarily realise what they are, but the really big challenge is, because I'm a compliance guy, the current definition of what a medical device is actually any device, instrument, apparatus, appliance, or any other article that is intended to be used for, on, or with human beings for a therapeutic purpose. So that's just a really narrow definition, really narrow. Being a former policy wonk, I can appreciate the ambiguity that went into that one. But the challenge is, who out there has got a wearable? Hands up? Yeah, no one's put their hands up now, are they? Does anyone else, if they're open to discuss it, things they might be carrying on their body or implanted for devices and that sort of thing? Don't worry, there's nothing today that will affect you, that sort of thing. But in actual fact, what is a medical device? It's not just things that go into your body. It's not like things like mesh or prostheses and that sort of thing. It's wearables, smartwatches, so Apple Health, all the data that's collected and part of that forms part of a medical device. Imaging, ultrasound and CAT scanning machines, medical equipment, anaesthesia machines, patient monitors, hemodialysis machines, device software. There's actually a category of medical devices, software as a medical device, where the algorithms and the underlying software encoding that goes into the device that makes diagnostic decisions and analytics is technically classified as a device in its own right. And then there's also the hardware that sits with it. But I guess one of the key things really is that when you've got a legislative framework that's over 40 years old, that is now governing something which is completely and utterly detached from what it was then, we have a real problem. And because most of these devices are generally governed by compliance and regulatory frameworks and other things like that, in New Zealand this is completely not fit for purpose. There is a piece of legislation that is currently under drafting, which I think is called the Therapeutic Products or Therapeutic Goods Act, where when I was time at the ministry, I was very keen to make sure provisions around the protection and management of medical devices were actually put into the legislation. But the problem is that it's still working through. And in New Zealand, there are only two organisations, technically, which can have a meaningful influence and govern medical devices in New Zealand: Pharmac and MedSafe. Now, Pharmac's traditional purview is they buy medicines and they're a procurement agency. I may have had a strong exchange with some seniors in Pharmac from time to time that explained what I thought about their position on that, and being lawyers, they went, no, this is what the legislation says. And I said, well, the problem is when these organisations build their devices and you want to bring them into New Zealand, you have got a digital duty of care to make sure they're giving us safe stuff to use for the population. Oh, no, we can't do that, Nick, because we might upset the manufacturers and they don't want to bring the devices to New Zealand. So I'm like, well, threat to life versus commercial gain. Where does that sit? There's some ethics discussions here, which we can talk over a bar about, but you know. And then we've got MedSafe. Now, MedSafe is a smaller business unit that's part of Te Whatu Ora, formerly the Ministry of Health. I think it's potentially part of the Ministry of Health still. They're responsible for the regulation, oversight, and recall of medicines in New Zealand, surgical mesh and the like as well. But, you know, I think I can safely say there aren't a lot of necessary individuals in that team. And when I was sitting down and talking to them, there aren't any technologists. They're generally people who are used to working in a clinical, medical, and a, if you will, a regulatory environment. This is not necessarily well understood. And when I sat down with some of the advisories from CSIA in the States and out of Australia, it was a case of, what are we going to do about it? And then there's another part as well, which also really bothers me, is a lot of these devices are out in the community. They're not just in hospitals. So you'll have insulin pumps or other forms like that where companies will sell them direct to the public. And my question is, what is our duty of care to protect those people? How do we support them? What happens if manufacturers want to push updates over the air to those devices? How can we trust the coding and the patches that go with that? What's reasonable to expect those patients to be able to manage and monitor their products so they don't cause them harm? And so on and so on and so on. Now, this up here gives you a bit of an idea of what are the most top connected devices in hospitals. A lot of this data is from the States, but it's probably not too dissimilar to what we have here in New Zealand. The next time you're in hospital, you're unfortunate to be, you look at the Ethernet port that's beside your bed, and then the insulin or the infusion pump that's plugged into it. Takes you a second look. You don't want to start pulling leads out, but it does get you to really think about things. So IV pumps, patient monitors. And what's more is the staff who are responsible for managing these are nurses, orderlies, clinical engineers. These people are not technologists. This isn't their core business. So they will plug it in and expect it to go. Then we have medical dispensers. These are PICS machines, which essentially every time you get medicine in a hospital, there's a central part where the nurses will go, or the doctors, and they get your medicine out, they scan your armband, and you get the meds out, and they go, right, Nick Baty, you're supposed to have 2 of those, 3 of those, or 1 of those. Yeah, they will do what the machine tells them to do. So there's this blind faith and reliance, trust-based stuff, which this sort of thing really can unpack quite seriously. We'll get there. Probably not holding my tongue right. Oh, maybe too far. Oh, there we go. Right. So what are the threats and vectors that can actually cause this? You know, what are the rat bags doing that actually cause this problem? So why do they do it? So a lot of it is through financial and political gain, through access to identity, financial and medical data stored in hospital systems or networks associated with medical devices, through selling of data, wide-scale disruption of services by gaining entry into hospital networks, the alteration or removal of medical device or therapy to impact lives from a deliberate political act or to target an individual, IP property theft, which is a big one, impugning the reputation of a device manufacturer, motivation to harm other individuals, and the curiosity and prestige, in other words, because I can. Now, one of the things that's also really interesting about this is does anyone remember the Sing Health breach a few years ago, which was a real ripper, and a lot of big PII, of big volumes that was actually compromised? Well, within that, there was some speculation that some of the motivators of the attackers was after senior political members of the Singaporean government's data, and in particular, data around particular medical devices. So this stuff does potentially happen. Why do they do it in terms of their And why do we have real challenges with this? What is the problem? Why do medical devices present such unique and big security challenges? We think, by and large, the commercial IT side of the house, this is a relatively known quantity. Why are these so much harder to deal with? Well, one, you've got, this is one of the reasons I'm so passionate about it, is you've got a whole range of responsibilities and stewardship that come with this. You've got the device manufacturers who are responsible for the development, the coding, the firmware, the testing. Then you've got those guys who procure the devices, who ideally don't necessarily have the support and knowledge to know what to look for about buying a safe product. Then you've got in a hospital environment, you've got clinical engineers who operate the devices and manage and maintain them, but they don't have any security or technology background necessarily. You've got the IT teams in the hospitals, which understand it as it's a network node or another network device or an endpoint, but don't have any clinical understanding what the impact would be if that device was altered or taken offline for patching. Then you've got the nurses and the doctors and so who actually manage and operate the devices who have no idea that it's expected to work. And then potentially you go out to the primary care environment, GPs, doctors, where these devices are also deployed out to the public and they just expect these sorts of things to go. And all the way through, you've got the constant theme of the device manufacturer wanting to do patching through, sometimes patching is only done through removable media, can't be done over the air. Device manufacturers also often prescribe that the devices, they're the only ones who can patch it. In many cases, because of the age and the vulnerabilities associated with these devices, they have to be segregated for their entire life of the device inside a hospital network. So some of these devices can be in commission for 10, 15, 20 years. So their entire life cycle of that device has to be separately segregated off net. So there's some real challenges with this. I mean, I remember going into, I won't specify the details, a hospital when I was in my job at the ministry, and the chief, the guys who are actually managing that portion of the network, they said, Nick, this device is worth $750,000. We've just got it. It's going to be with us to 15 to 20 years. The operating system's based on Vista. It's hard-coded creds, and the only person who can change anything with it is a manufacturer who has to come from Australia and physically interact with it themselves, and we cannot supervise what they're doing. I thought, right, you're having a great day. So that's the sort of stuff these guys are up against. And the problem is in many cases, they don't know where all the devices are because no one's necessarily taking the time to register them, and developing a meaningful asset registry or an asset environment is really difficult. So, as I said, the other challenges they're also facing is certification agencies publish the device verification information with publicly accessible patent databases. So, awesome, own goal, everyone loves that. Legacy operating systems and software and incompatibility between systems leaves vulnerabilities such as misconfiguration and security holes. So, it's like the warrant of fitness on my car. There's problems, but I can't do anything about it. Lack of timely software updates and patches. Because remember, these devices aren't necessarily built with security by design. They're about trying to get the device to market as fast as possible before the other guys do. So lots of money goes into marketing, lots of money goes into development and elegance and using all sorts of functionalities such as Bluetooth and cloud as your friend and all sorts of cool stuff like that. Lots of stuff over the air. But security, they don't say no, it's bad. They're just like, it adds to the cost, it adds to the overheads, it causes extra challenges along the way as well. Web services are a popular solution for defacing existing systems, and as some of the previous speakers have said to me, all websites are secure, code has never got any problems with it, and everything's cool. So that's never going to be a problem at all. Medical devices, most of them do not have any form of basic security features at all, and they can also be used to attack other portions of the environment. So you compromise that as a device, then you can use that to then impact and infect other devices as well, or other portions of the network. You can have complex risk management governance regimes. It's like, that's my problem. No, it's your problem. No, it's your problem. No, it's my problem. It's his problem. Sounds familiar, but it happens in the medical device area too. So having a conversation at a health sector table going, how are you guys managing your medical device fleet is very much a case of moving cybersecurity chairs around the Titanic sometimes. Potential harm to patients and users from adverse medical device reactions can include physical harm. And I guess this is one of the biggest things that gets me really revved up is this is one of the few instances that I can categorically say this will, if it goes wrong, will literally potentially cause loss of life or kill someone. The worst that often happens when we have a serious incident is a really bad day at the office, a privacy breach, everyone gets, someone will lose their job potentially, but this here, someone could actually lose their life. And that's the key distinction here. Personal health data, it goes without saying, can be compromised. A lack of awareness of the cybersecurity issues. Limited power resources of medical devices, things like encryption cannot be applied or slows down the device or reduces the usable battery life. So things that we kind of know are really important are not even necessarily an option. So it becomes really challenging. In terms of, this is the fun part, good war stories. Some of the things we've seen. In 2021, 2022, the health sector faced a nearly 800% increase in cybersecurity attacks globally. The industry has actually experienced the highest average attempted intrusions in 2022, last year, and IOMT, Internet of Medical Devices, saw a 123% increase in attempted breaches last year. You've got a bit of an idea of some of the breach issues or some of the issues that have actually happened in the last wee while. February last year, there were 7 vulnerabilities associated with certain devices to do with the PTC Accessor agent, which actually meant that the medical devices could be remotely accessed and conduct remote code execution, alter the system configurations. Implanted defibrillators had telemetry protocol flaws. Some implanted defibrillators were found to contain vulnerabilities that allowed them to be exploited by attackers. And actually, within close proximity, the individuals possessing it could actually recompile the code base. Some of you guys may have heard this story about Dick Cheney. There's some issues with his pacemaker. They actually found that if someone with the right motivations and technique could actually get close enough, they could impact his pacemaker. So the Secret Service were like this the whole time around and making sure people were kept away from him. Poor security in PACS machines. Now, PACS machines are a really interesting case. Those are the machines that when you go in for a CAT scan or an X-ray, that store and help analyse the data. You know, the X-ray image and the images that oncologists and other specialists look at. These are the systems that render the images into digital, essentially digital images that they can actually manage and share and store. What they actually found, there was one great thing, is that sometimes there were compromises of the repositories, sometimes there were compromises of the platforms, and in many cases, we'll talk about a little bit later on, there was also compromises of the base source code of the imagery, where they actually found the DICOM-based image had been compromised. This happened, I think it was 2019, and they were able to identify instances where the actual imagery of the X-ray or CAT scan had been maliciously altered to the point where the specialist was making incorrect diagnoses and telling people when they had cancer they didn't have cancer and vice versa. And that was I think the CVE on that one was about 8. And that was 0 day and they managed to get it sorted. But this was a source code that was used globally for all medical images. Insulin pumps, anaesthesia machines, they were also indicated the software bugs were so serious that anaesthesia machines, they actually found just by plugging the phone or a device into the USB port, they could compromise the machines. Now, hats off to Bogan, who's the man for us. He gave me some insights as well about a gentleman I didn't actually know about, a guy by the name of Barnaby Jack. He was a Kiwi from Auckland. Some of you in the audience may have heard him before you met him. He actually demonstrated in 2011 at the CAFE conference in Vegas that he was able to actually, using high gain antennas, alter and manipulate insulin pumps, essentially allowing the device to completely empty its dispensary in, say, 20 or 30 seconds and effectively overdosing the individual just by remote access and killing them. At the RSA conference in 2012, he used a transparent mannequin that he actually wirelessly hacked into an insulin pump from a distance of up to 90 metres away with a high gain antenna. And then in 2012, unfortunately, I think he passed away just prior to this point, he was able to demonstrate the ability to effectively hack their pacemakers and deliver life-threatening, potentially fatal shocks. So, he was a real bit of a legend and a grandfather of this type of stuff. So this has been around for a while. It's just not necessarily seen as a big issue, but it is. So, these are generally the most insecure devices around. So that is obviously the bedside infusion pump. On the left-hand side there, ultrasound, patient monitors, medical dispensers. I spoke a little bit about those in terms of they dispensing medication at the bedside. Internal gateways, IP cameras, sometimes they're using that observation, the PACS servers, various different diagnostic imagery tools, and the DICOM workstations and the PACS servers work together in that regard. So, what are SBOMs? Yeah, we've spoken a little bit around that. There was when I ran through that sort of stuff there. What are SBOMs and how they make digitally devices safer? So essentially an SBOM, I love that name. I love it when my kids like, I've got an SBOM. Like, what? A software bill of materials is essentially an inventory of all software components, proprietary and open source licenses, dependencies in a given product. I kind of think of it like as a warrant of fitness. All the things that's wrong with it, you've got to fix when you buy it new. Given to a particular product, and they include libraries, drivers, firmware, licenses, and operating systems. Now, the reason they are really important, and they're getting some traction in the States, but they're not much further than that, and I really wish they'd bring them in here, hence the talk. SBOMs provide greater transparency and enable medical device manufacturers and healthcare operators to identify vulnerabilities and monitor medical device security more effectively. By knowing the components of software installed on a device, they can save 100 hours of risk analysis, vulnerability management and remediation process. Now, there's a lot goes on to them, and the thing is, what essentially they do, essentially you have asset discovery first, where the medical device suppliers are typically compiling multiple software components for their customers, including firmware and binaries, client applications that run on the customer's computer, APIs to send the data to, and mobile applications that run on smartphones. Beware of Apple Health sometimes, I wonder. Then obviously the SBOM's created with attestation and signature. Now the key thing about this is making sure that the SBOMs really need to be attested to by an independent third party, because essentially it's that whole trust and assurance. It's been done properly, but yeah, trust me, it's all good. No worries there. You're actually having an independently verifiable, capable third party to verify that SBOM is actually been well constructed and is complete. And then you also need to be able to store it securely with what's known, a strong and effective authorization layer. Generally, centralized storage can be such as an S3 bucket or other secure managed file servers, but they need to make sure it's done encrypted, because of course, if you can compromise the SBOM, then it renders it useless. And then, of course, having the ability to be searched effectively, so you can actually look it up, access it effectively, and keep them up to date. And this has been something I've been talking about with health sector colleagues for years, because a lot of people are like, if we knew what the problems were, or potential problems when we bought it, we accept that that might be the case. Then we can manage it more effectively. It's kind of like, here's this really big capital asset you bought. Cool, there's some problems with it. I don't know what they are. I can't tell you, but good luck. And that's kind of what these guys are kind of having to deal with. There is hope. So the national, actually full extent here, there's a couple of organisations in the States, including ISACA, has actually been working with, and MITA and the FDA. This is what the Americans actually kind of get the big guys together and kind of work on this stuff. And the medical device industry have been developing what's called the Voluntary Improvement Program, where they're starting to develop mandatory and minimum standards and criteria for what SBOMs actually should look like and the components that go into them, and a maturity model. So everyone, again, we love our good frameworks. Everyone can actually understand how the device they're buying fits into it and what's reason to expect and what's an improvement pathway. And actually what was really cool is in March of this year, the FDA started enforcing the requirements for SBOMs by inquiring a cybersecurity bill of materials. But I guess one of the big challenges that we have here is we're not the FDA and we're not the US. And because most of these medical device companies are based in Europe and North America, our ability to influence these outcomes is much, much smaller. So why is this, what can we do about it, and what could actually be, how can we approach it here in New Zealand? And this is where because I'm all about kumbaya and warm cuddles, often called the Cybersecurity Council, let's talk about this, it'll be okay, is how do we actually deal with this? And that's why I use, the Weasley policy term, using a partnership-based approach, which means everyone talks in calm voices and no one yells. But essentially, it's finding a way, and I was lucky enough when I was in the ministry to talk to the global CISO for Becton Dickinson, which is one of the largest medical device manufacturers in the world based out of the States. Getting the medical device manufacturers and Pharmac and MedSafe and Te Whatu Ora and central government, and by the way, we will solve all the other world's problems as well, to try and work out how it will fit together and what we could actually do. Because the thing is that that's the diagram on the right, to work out how it all sort of fit together. In that particular regard, one of the things I'm trying to do is, how do we get the medical device manufacturers to actually be more transparent and to offer more information and insight about what goes into this? This is where our friends in Australia and the US and the EU can be quite helpful, because they're leagues ahead and they've got a lot more resourcing. And I don't normally do it, but I will give kudos to the Australians, because a couple of years ago, the TGA, the Therapeutic Goods Authority in Australia, which is the Australian equivalent of MedSafe, released a really, really practical, sensible medical device cybersecurity risk management framework for healthcare organisations as well as industry players about how to manage it. It was modelled heavily against the ASD Essential 8 and other frameworks such as that, to how to practically manage this at a life cycle level. Because they essentially said, look, it doesn't matter where you are in the life cycle of managing medical devices, you still need input from other parts of the supply chain. You need to know what vulnerabilities there would be, which means the medical device manufacturers need to be able to pass it to you in a protected disclosure format. And that presupposes the lawyers haven't got over it and diluted it so much so it's no longer effective. There's a higher element of trust that needs to be built into the framework. It also presupposes the likes of Pharmac goes, okay, we accept we're not just buying stuff, we've actually got a duty of care to enforce minimum standards of security and resilience in these devices when they come into New Zealand, accepting, of course, that Pharmac isn't the only way these devices can be bought. But as I said, it's not just about buying the stuff, it's actually, if you want leverage to change something, it's about putting stuff in contracts to make sure these guys actually only give you capable and safe stuff. It's about supporting the folks at MedSafe. Look, this is a really important area. What are we going to do about it? And I know certainly, like I've spoken to a couple of former colleagues today, it's an issue that's on the radar, but it's a big issue and it's taken a lot of energy, and it's one of many, many things that Te Whara Ora and their cybersecurity uplift work are thinking about. So it's about being kind and fair and reasonable, but saying, well, where does this fit into your scheme of priorities? As I said, Te Whara Ora, when I was the Ministry of Health, I was one of 3 people doing cybersecurity across the health sector. Yay! Now there's a lot more, which is great, but they're doing a lot more and covering a lot more ground, and we're actually working with a sector which traditionally has had a patchy track record around cybersecurity, and we're getting better, but it's going to take some time. And also recognising how we reasonably work with each other on that sort of space. And of course, our central government, when I was working in Wellington, it was a case of we spoke to the National Cyber Policy Office and we spoke around what IoT security looked like. But one of the things I observed is that IoT security in that context is traditionally thought about at a retail consumer grade level. We don't really ever think about it at an OT medical level in that regard. And I said, well, in terms of harm to the New Zealand public, which is the first responsibility of any government, is to secure and the health and welfare of its citizenry, how does that fit together? And most of the stuff, as we say, is built to the lowest security grade, because security is not in mind. We're trying to build stuff to sell it, to make money, so the mindset's different. So it's working out how those components sort of fit together. But as I said, there is real cultural and structural balances. It's not well understood. Cybersecurity is still a complex and fractious topic in the health sector, if I'm polite about it. It's one of those things that everyone says there's not enough money for, and I always say, well, let's spend the money you've already got properly, which wasn't always a popular opinion. And there's also still a massive lack of cybersecurity professional capability within the health sector, particularly around procurement and oversight. They are doing something about it, but as we all know, the cybersecurity industry is screaming out for capable people right around the world, and certainly it's no smaller here. There's a lack of capacity within Te Whara Ora across the health sector, so they're going, well, what's a reasonable and sensible approach here? I hate to say it, but it's commercial imperatives versus cybersecurity, and that was one of the hard lessons I had to learn. It's saying, well, I know you want to change the world, Nick, and I know you want to do something about this, but the problem is that if we're too harsh and demanding with these device manufacturers, they'll just take their devices and go and sell them somewhere else and not sell them in New Zealand. So ultimately, the consumers and the digital health consumers and patients are the ones who lose out, because the New Zealand health sector market, medical devices, is tiny compared to what they'd be getting in Europe, North America and Asia and even Australia. So it's about, well, what's the right balance we can strike? So very much a long game conversation, and I'm impatient and stroppy and I like to get things done now, so this has been a hard one for me. And as you say, the market's very small, and the people who understand this and manage it is a really small number as well. I've got out of 300 more to it, so that's cool. So what can we, the royal we, do about it? What could we do about it? And this, I guess, is a bit of a call to action and challenge for the audience here, because we're full of rooms of security professionals, and in the potential event that you're asked by a health sector organisation to help them out and understand this technology, which does happen from time to time, I guess be a nice guy. Don't be a dick about it. help them provide constructive and useful and supportive advice and collaborative support, saying, what about this, what about that? Because this is a massive issue and they're really trying to get their arms around it and they don't often understand how to approach it. Encourage responsible behaviour. And sometimes that means refereeing appropriately between clinical engineers and these guys here, saying, look, you're all on the same team. Yes, I get the responsibility and stewardship that isn't always necessarily that well understood, but we've got to find a way to get on top of it properly and finding some common ground. I did this talk a couple of times at ITF and other bits and pieces as well, but I've often thought that the ITF or the New Zealand IT Alliance, this is one of the more capable groups of professionals in New Zealand. Why couldn't there be a potential working group set up to coalesce those who are interested in the skill and capability to go, look, we're not going to solve the problem, but we might have a collection of resources and capability to try and help come up with a particular disclosure framework or a way of providing help people identify what that looks like, how to ask the right sort of questions around what a potential SBOM would look like. If you get one, what the components you need to look into it, how can you meaningfully address that? Because one of the biggest areas that they need support is the procurement guys, because they're the ones doing the negotiation with the device manufacturers. And then, dare I say it, if you actually asked to look at this stuff, getting them to actually, encourage them to ask really good risk-based questions. Things like, has security been considered in the design of the device? Does the intended use of the device expose it to risks associated with cybersecurity? Because very often you are dealing with people in this space who have no technology versus virtually no security background at all. And is there a possibility that the vulnerability may lead to the medical device actually impacting the health and safety of the user? Has it actually been considered in the total product life cycle of the device? Because this is one of the few things I've seen where you really do have to consider the risk and totality across the life cycle. You can't just say, right, when it's in operation, that's all we have to care about here. It's actually, because there's such an interdependency versus each stage of the life cycle that one pulls the other, you have to consider it in its totality. Can you regularly maintain it? How would the device be maintained? Does it require external intervention from manufacturers? Does it have to be done over the air? How do we segregate and manage it? Will it actually require regular patching and updating to maintain minimum viable safe performance and standards? Does the risk assessment potential intrusion, outweigh the potential risk of the device? How often does it have to be taken offline to patching versus how long it can be made available to patient care? Because if you talk to anyone in a hospital environment, there is, it's the classic example. There's actually no good time to take systems down for patching or do stuff offline. It's just, it's like, who's going to screen the list is the ones you talk to. And could the device be compromised throughout its supply chain and transport systems? And as we're seeing the greater use of AI for algorithms and the use of Bluetooth and Wi-Fi and cloud for remote access by specialists, there's so much technology and capabilities being thrown in these devices for good clinical reasons. But in doing so, there's all the hassles and problems and challenges and sharp, pointy bits that go with it. So it's just think about how can we manage this together and what is a sensible place to start. Even just building awareness around the conversation is going to be key. And that's me. Thank you for your time today, folks, and listening. Happy to take any questions if there are any. I was really worried because I was right before lunch and I thought they're going to kill me if I run over time. Any questions or queries? If not, come and grab me at the break and I'll give them a rant about more scary stuff.
Busted!